4 completely different products, one jaw-dropping journey. From the raw steel of a riding mower to the carbon atoms of a diamond, the precision of a bed, and the science of popcorn. Did you know it takes 1,000 tons of pressure to shape steel into a mower deck? Or that a single popcorn kernel has to hold just the right amount of moisture to pop? We'll break down each process in simple, step-by-step detail. No engineering degree required. Get ready to see how raw materials turn into everyday wonders, one fascinating transformation at a time. Let's start at the very beginning, where a flat sheet of steel is about to become something much more. If you're into this kind of transformation, go ahead and like the video, subscribe for more, and drop a comment telling us where you're watching from. Inside the factory, the transformation of a riding mower kicks off under bright overhead lights and a constant hum of machinery. The main event? Turning a massive, unremarkable coil of steel into the deck that will anchor the whole machine. Robotic carriers haul these heavy coils onto the production line, where they're unwound and fed into a series of rollers. The steel glides toward a huge die, and then 1,000 tons of pressure slam down, shaping the steel into that familiar curved shell. This moment sets the foundation for everything that follows, demanding both brute force and careful precision. After pressing, CNC-driven punches and trimmers make each hole and edge perfect in one automated pass. Every opening for bolts, spindles, and hardware is cut to exact measurements. The trimmers smooth the edges, so each deck is safe to handle and ready for assembly. Computers guide the process from start to finish, ensuring not a single hole is out of place or edge left rough. It's fast, it's accurate, and it's all about making sure the next steps go off without a hitch. But steel has its own set of problems. It's tough, but it doesn't like moisture. So the next stop is a thorough wash and a chemical rust inhibitor bath. The metal is scrubbed clean of oils, dust, and anything else that might mess with its finish. The rust inhibitor forms a barrier to keep moisture out, which is crucial for a product that'll spend its life outdoors. Skip this and you're looking at rusted decks and unhappy customers. Now comes a high-tech twist, painting that's more science than art. In the paint booth, an overhead rack gives the decks a negative charge, while the positively charged primer particles cling evenly, a process called electrostatic painting. This isn't just about color. The charged particles wrap around every curve and corner, giving the deck a smooth, even coat. It's a finish that stands up to rain, sun, and flying gravel. Any stray powder that doesn't stick gets sucked up and reused, so nothing goes to waste. The end result? A deck that looks good and shrugs off the elements. With the deck ready, the real assembly begins. Bolting and belt fits happen in moments. Spindles are attached, blades are mounted, and belts are looped around pulleys. The rails that form the mower's frame are welded by robots for consistency, then painted for durability. The engine subassembly is lowered into place, turning a collection of parts into the heart of the machine. Footrests, seat platforms, steering levers, and wheels all snap into position with practiced efficiency. Ever wonder which tasks still need a human touch? Stay tuned to find out. Workers handle the tricky jobs, securing bolts to the right torque, aligning parts so everything runs smoothly, and checking that nothing's off by even a millimeter. Robots handle the repetitive stuff like welding and spraying paint, but it's people who make sure the mower feels just right when you sit down to drive it. This blend of automation and skilled labor keeps things moving fast without sacrificing quality. Once the mower looks like a finished product, it's time for quality control. Each one rolls into a test bay for wheel speed calibration and durability checks that simulate a decade of use. Sensors flag any issues, like a spindle that's out of alignment or a blade that vibrates too much. Workers do visual inspections too, making sure the paint is flawless and every bolt is secure. Some mowers are randomly pulled for more intense testing, run at full speed, put through their paces, and checked for any sign of weakness. Only after passing all these checks does a mower get the stamp of approval. The entire process, from the first press of steel to the final inspection, takes just over an hour, about 72 minutes. It's a combination of speed, precision, and constant checking that lets a single factory turn out hundreds of mowers every day. The finished machines line up at the end of the assembly line, ready to be shipped out, each one gleaming and built to handle years of work. It's a fast, complex process, but every detail is there for a reason. That's what it takes to turn raw steel into a reliable mower that'll handle everything from small yards to massive fields. And while the journey from metal to machine is impressive, the next transformation on our list is even more surprising because it starts with something much smaller and ends with a snack almost everyone loves. Popcorn might look simple, but the way it gets its crunch is anything but basic. This snack has a backstory that stretches thousands of years. Archaeologists have found popcorn kernels in New Mexico caves that are over 5,600 years old. The wild part? Some of those ancient kernels could still pop. That's how long popcorn has been impressing people with its unique trick. Not all corn can do what popcorn does. Out of the 6 types of corn, popcorn is the only one with the right build to pop. Its kernels are small and dense, with a hard outer shell that holds everything in. Farmers spend years breeding popcorn plants to get the best color, flavor, and that all-important popability. This isn't just about taste, it's about making sure every batch delivers on that satisfying crunch. The process starts in the field, where popcorn plants grow a bit shorter than regular corn. When the ears are ready, farmers harvest them and peel back the husks to reveal rows of tightly packed kernels. At this stage, those kernels are too moist to pop well. They usually hold between 16 and 20% moisture. If you try to pop them now, you'll end up with chewy, half-popped bits. That's why the next step is so important. They condition the harvested crop in large bins to lower moisture from around 16 to 20%, down to the ideal 14%. This careful drying is what makes the popcorn pop big and fluffy, instead of small or tough. Once the popcorn reaches the right moisture level, it heads to the processing plant for cleaning and sorting. The first stop is a series of oscillating screens. Think of them as vibrating trays with small holes. These screens shake out any stray bits of cob, dirt, or even the occasional piece of broken glass that slipped in during harvest. High-speed screens and airflow systems keep out debris and undersized kernels, ensuring only the best continue. This step is all about consistency. If a kernel is too small, too light, or damaged, it gets removed. The goal is to send only the uniform, high-quality kernels down the line. With the kernels sorted and cleaned, the science behind popcorn's pop comes into play. Every kernel has a tiny bit of water tucked inside its starchy center, all sealed in by that tough outer shell. When you heat the kernel, the water turns into steam, building up pressure. The shell holds on as long as it can, but eventually it bursts. The inside starch expands super fast and then sets as it cools, giving you that light, crunchy texture. If the moisture's off, even by a little, the whole process fails. Too dry and nothing happens. Too wet and you just get a chewy mess. Factories don't stop at just cleaning and conditioning. Each batch goes through strict quality checks before it ever hits a bag. Workers and machines weigh and measure the popcorn, making sure every package is consistent. They even track the number of unpopped kernels, those old maids everyone finds at the bottom of the bowl. The aim is to keep those to a minimum because nobody wants to bite down on a hard kernel in the middle of movie night. Popcorn's journey from field to snack isn't just about technology, though. There's a whole history behind why we eat it the way we do. Early civilizations used popcorn not only for food, but also in ceremonies and as decoration. Over time, it found its way into fairs, carnivals, and, eventually, movie theaters. That's where popcorn really took off. The smell of fresh popcorn became part of the movie-going experience, and theaters quickly realized people were willing to pay a premium for it. In fact, theaters mark up popcorn by over 1,000%. For many, though, the taste and smell are worth every penny. What makes popcorn stand out is how it brings together ancient tradition and modern science. One tiny kernel, about the size of a pea, can expand to many times its original size in seconds. You can find it everywhere. coated in caramel, dusted with cheese, or just lightly salted and buttered. Its appeal is universal, and the process behind it is a mix of careful farming, precise engineering, and a bit of natural magic. After all the sorting, cleaning, and packaging, those kernels are sealed up and shipped out to stores and theaters all over the world. It's a full-circle journey, from seed in the ground to snack on your lap, all thanks to a blend of old-school know-how and new-school technology. Popcorn proves that even a classic snack relies on careful science and quality control. But not every product is so simple. Some demand a whole new level of engineering, especially when comfort, health, and technology have to work together. That's where adjustable beds come in. Precision and comfort might sound like marketing buzzwords, but for adjustable beds, they're the foundation of every design and build decision. These beds are all about giving you control, raising your head, lifting your feet, and dialing in the perfect position with just a button. That means every part, from the mattress to the motors, needs to work together seamlessly and hold up to constant use. It starts with the mattress, which is anything but ordinary. A quilting machine stitches foam, fire-retardant layers, and backing into a panel with thousands of uniform stitches for durable comfort. This single step creates the plush top you feel when you first sit or lie down. And those stitches keep the layers from shifting or bunching up over time. Machines then cut the quilted panels to precise sizes, so they line up perfectly with the rest of the mattress. No awkward overhangs or mismatched seams. Beneath that quilted surface, the real support system comes together. Workers wrap the spring assemblies in protective netting, then top them with high-density foam for even weight distribution and extra support. This combination means the mattress stays comfortable and holds its shape, even after years of bending and adjusting. The foam pads smooth out pressure points, while the netting keeps the springs working together as a unit. Building the foundation is where things get interesting. Platform boards form the base, and flexible nylon hinges are stapled between them. These hinges are what let the bed bend and move while still holding everything together. Next, a steel frame is bolted to the platform, adding the strength needed to support both the mattress and the person using it. The frame also acts as the anchor point for the electronics and motors that make the bed adjustable. Integrating the motors is a careful job. Workers attach head and foot motors to the steel frame, connecting them with a worm screw and gear system. This setup is what allows you to raise or lower different sections of the bed with smooth, controlled movements. The gears and screws have to line up perfectly. If they don't, the bed might jam or move unevenly. That's why each assembly is checked and adjusted by hand before moving down the line. Before these beds ever reach your bedroom, they must pass a grueling flex test. Think thousands of bends in minutes. During testing, the bed's motors are run through every possible position, and the frame is flexed repeatedly to simulate years of use. Any jerky movement, unusual noise, or sign of weakness gets flagged. The idea is to catch problems early, so the final product is reliable right out of the box and for years to come. The finishing steps focus on both safety and appearance. A tape edge machine creates a strong seam around the mattress using fire-retardant thread, locking all the layers together for safety and durability. Even though it's just a seam, it's one of the most visible parts of the whole bed, so it has to look clean and feel secure. If the seam isn't perfect, it's obvious to anyone who sees or touches the mattress. Customization is a big part of what makes adjustable beds stand out. Some models come with built-in massage systems, extra motors for adjustable headrests, or even smart features that let you control the bed with your phone. Workers add these features based on each order, carefully integrating extra motors or massage units into the frame and running wiring through special channels. Massage motors are placed to spread vibrations evenly, and adjustable headrests get their own hinges and controls. Despite the added complexity, every customized bed goes through the same rigorous testing as the standard models. When everything is assembled, inspected, and tested, the bed is cleaned up and prepped for shipping. Each part, motors, seams, frame, and mattress, is double-checked for quality. Only beds that meet all the standards make it out of the factory. Whether they're heading to a hospital, a home, or a hotel, each one is built to deliver comfort, support, and reliability for the long haul. Looking at the finished product, it's easy to forget how much engineering and testing goes into something as simple as a good night's sleep. From the carefully stitched panels to the precision gears and motors, every detail is there for a reason. And while adjustable beds are a clear example of how technology can improve everyday comfort, there are other products that push the limits of what's possible, especially when it comes to recreating nature's most prized materials in a lab. Diamonds might look like simple gemstones, but the story behind lab-grown diamonds is all about control, turning pure carbon into a crystal with the same sparkle and strength as those formed deep underground. From carbon to crystal, the art of growing. Cultured diamonds isn't just about shiny jewelry. It's a showcase of how science and engineering can create something extraordinary in just a matter of weeks. Natural diamonds form under extreme pressure and heat, buried deep beneath the Earth's crust for billions of years. Scientists figured out how to speed up this process in the lab using two main methods: chemical vapor deposition, CVD, and high-pressure, high-temperature, HPHT. Both start with a tiny diamond seed, but the way they grow the final crystal is what makes each process unique. Let's look at the CVD method first. It all starts with a Type 2, a diamond seed, the purest kind, chosen to keep out any unwanted impurities right from the start. These seeds go into a vacuum chamber where all the air is pulled out to prevent contamination. The chamber is filled with a carbon-rich gas, usually methane, and then heated to about 800 degrees Celsius. At this temperature, the gas breaks apart and carbon atoms settle onto the seed, building up the diamond one layer at a time. The process is slow and precise. Even a small change in temperature or gas flow can mess up the crystal structure, so everything is monitored closely. After a few weeks, the result is a rough diamond that's chemically, physically, and optically identical to a natural one. Once cut and polished, you wouldn't be able to tell the difference, even under a jeweler's loupe. Now for HPHT. This method tries to copy the Earth's own recipe for making diamonds. A diamond seed and a source of pure carbon, like graphite, are placed inside a special press. The press subjects them to pressures up to 5 gigapascals, around 725,000 pounds per square inch, and temperatures above 1400 degrees Celsius. Under these conditions, the carbon melts and atoms start to attach themselves to the seed, growing a new diamond crystal. HPHT can produce larger, single crystal diamonds and is often used for both jewelry and industrial applications. The scale of the equipment and the forces involved are pretty wild. Think of a machine squeezing carbon with more force than what's at the bottom of the ocean, all while heating it hotter than lava. Both CVD and HPHT make diamonds that are nearly impossible to distinguish from the ones dug out of the ground. But it's not just about making something pretty. Lab-grown diamonds are changing the industry in big ways. For starters, they're a lot more affordable. Growing diamonds in weeks instead of waiting for nature to do its thing over millions of years means lower costs. That savings gets passed on to consumers, so you can get a bigger or higher quality stone for the same price as a smaller mined diamond. Traceability is another big perk. With mined diamonds, it's not always clear where they come from, which raises concerns about conflict diamonds and environmental damage from mining. Lab-grown diamonds, on the other hand, come with a clear record. Labs can track each stone back to the exact chamber and process used to make it. This transparency helps buyers know exactly what they're getting and where it came from. The environmental impact is also a major difference. Traditional diamond mining can cause deforestation, soil erosion, and even displace entire communities. Lab-grown diamonds skip all that. The lab processes use much less land and water, and while they do require energy, ongoing research is focused on making production more efficient and sustainable. Some labs are already finding ways to recycle materials and cut down on waste, making the process cleaner as technology improves. Lab-grown diamonds aren't just for rings and necklaces either. Their hardness and thermal conductivity make them valuable in all kinds of industries. They're used in cutting tools, grinding wheels, and high-precision drills that need to last a long time without wearing down. In electronics, diamond coatings help pull heat away from sensitive parts so devices run cooler and last longer. And in quantum computing, lab-grown diamonds are at the cutting edge. Their unique atomic structure lets them store and process quantum information, acting as qubits for some of the most advanced computers around. But with all this tech advantage, why do some still hesitate to buy lab-grown? Part of it comes down to tradition and perception. Many people see natural diamonds as rare treasures, each with a backstory stretching back billions of years. There's a mystique to owning something that old, and for some, that's worth more than the diamond itself. Others worry about resale value or whether lab-grown stones will hold up as heirlooms. Still, the gap is closing. More jewelers are offering lab-grown diamonds, and as people learn more about how they're made and what they represent, opinions are shifting. When you look at a finished cultured diamond, it's wild to think it started as a microscopic seed in a high-tech chamber. Some end up sparkling on engagement rings, others get ground into tools tough enough to cut through metal, and a few are powering the next wave of computers. No matter where they go, each one is proof that a mix of science, engineering, and a bit of patience can turn something as simple as carbon into something extraordinary. So next time you see a diamond, whether it's in a piece of jewelry or part of a machine, remember, there's a whole world of innovation behind that sparkle. And if you start looking closer at the things around you, you might be surprised by the stories hidden inside everyday objects. From pressing steel to growing carbon crystals, everyday objects hide incredible journeys. Riding mowers start as flat sheets, and diamonds form in labs under precise conditions. Proof that manufacturing combines engineering, science, and a lot of careful planning. Each step, from the popcorn kernel's moisture control to the adjustable bed's flex test, shows the innovation and skill behind the scenes. Next time you fire up your mower or pop a bag of corn, remember the engineering and science that made it possible. If you enjoyed this behind-the-scenes look, hit like and subscribe for more factory tours. There's a whole world of manufacturing marvels still to explore.